all know that mountain peaks' height is measured from sea level. For example, the height of Mount Everest, the highest mountain in the world, is 8,848 meters above sea level. Let's have a look at the map. The distance from Mount Everest to the nearest sea is 700 kilometers, which is rather a lot. The mountain cannot be seen if you are near the sea. So what do people mean by mountain height above sea level? To deal with that, we need to understand first what is meant by sea level. There's no sea at hand at the moment, so we'll be looking at the water in this jar. Sea surface is horizontal, and the water surface in the jar is horizontal as well. When we tilt the jar, the water surface does not move along, but stays in the initial position. So how does the water know what position to take? The thing is that this position is the lowest possible. If one side of the surface was higher than the other, the water would just flow downwards and its surface would level itself. The plumb bob indicates the direction in which all bodies are drawn towards the earth. The horizontal position of the water surface in the jar is perpendicular to the plumb bob. Let us imagine a round earth fully covered with water, a kind of ocean planet. Sea level should be considered equal everywhere on such an earth, by default, and it should be taken for a zero elevation reference. All the plumb bobs will be radially directed to the center of the earth and be vertical to the sea surface. In this drawing, you see part of such an earth and two plumb bobs. Let's draw a mountain on the left and an ocean on the right. How can we measure the mountain's height from sea level if the sea is rather far away from it? We draw a canal going from the sea down to the point right underneath the mountain peak. The canal fills with water. We put a plumb bob down the mountain from its peak to the water level and measure the mountain's height by the plumb. We could draw a tunnel instead of the canal, making it go vertically down the mountain, then bend towards the sea and connect with it underground. The tunnel will fill with water up to the level of the sea, which will allow us to measure the mountain's height. We cut off the bottom of a bottle, connect it to a glass tube through a rubber hose and fill it with colored water. Such a device is called communicating vessels. We can see that the water in the vessels is leveled. If we raise or lower the tube, the water will move to level with the water in the bottle. If we move the tube away from the bottle, we see that the water in the vessels is still leveled and is strictly horizontal. So why is liquid in communicating vessels always leveled? We can explain this phenomenon in a number of ways. Let's examine horizontal water surface after coloring some part of it. We encapsulate the colored part of the water. The water within the capsule does not undergo any changes and keeps its initial level. If we remove all the water on the outside, we get a regular picture of communicating vessels. The second explanation is based on the principle of the impossibility to create a perpetual motion machine. If the water in the two communicating vessels was not leveled, we could make holes in the walls of the vessels and let the water flow along a trough from the upper vessel into the lower one. The water could come back through the lower connection. This flowing water could turn the wheel of a turbine and thus do mechanical work. Yet another explanation is based on the fact that the system's gravity center always drifts towards the lowest point. If the water level in two communicating vessels was different, we could move part of the water from the upper to the lower vessel, and the system's gravity center would evidently lower itself.